Hello, welcome to the second part of the theory class about XSD. Just reviewing what we've seen last class, on the first part of our theory class about XML schemas, we've seen an introduction and differentiation between XSDs and DTDs. We've also seen some characteristics of XSD and started seeing the syntax, the general syntax of XML schemas, basically the prologue, the schema element, and the attributes of the schema, including the declarations of all default and custom namespaces and prefixes. And we finished seeing the three methods used for designing and organizing the declaration of the components throughout the XSD code. The simple method, the divided method, and the named types method. So now let's continue our theory lecture about XSD. On this specific syntax section, we'll talk mainly about four subsections, which will be the simple elements, the attributes, the complex elements, as well as the data types, and all the constraints and declaration issues associated to these four main components of any XSD, as well as of their document instances. So let's start with simple elements. Simple elements can be declared at the XSD as below. We've seen a lot how to use simple elements on XML instances, and now we'll see how to declare them at the XSD documents and how to constrain these elements regarding their data types, as well as some other constraints that we'll show you in this subsection. So simple elements can be declared in a short form and in a extended form, and we'll see the differences and when you have to use the extended one. But let's just focus on the definition of what simple elements are for now. So simple elements can only contain text data, cannot contain elements, any elements nested inside, and also cannot contain attributes. So simple elements, regardless of what constraints we may apply to them, can only have as content text data or info data. And this text data can be restricted or constrained inside the declaration at the XSD document through built-in or custom data types, as well as by restrictions or facets. So let's first see here the two forms of declaring simple elements, and next we'll see those restrictions that we can apply inside the declaration of these elements. So if you see here, we have these two forms of declaring a simple element. One, a simpler inline form where we use the default prefix that's associated to the default namespace from W3C. Column element, this means we are declaring an element. Then we use the attribute name to name this element. All elements must be named. And then we simply set the type using the type attribute equals, under quotes, the prefix, which can be the default prefix from W3C. If we are using base types from W3C, for example, XS column string or XS column boolean, or this prefix can be any custom prefix from any other namespace that links to any other declared type within that document or at any other document imported to the XSD, and giving access through the column here to the type we want to set. So this is the simpler form of declaring a simple element, and you just use the slash at the end of the opening tag here for avoiding to use a second tag or a closing tag outside, as we've already shown in a lot of other examples when we saw XML syntax. So this is the shortest form for declaring a simple element. But we have another option, and sometimes it's not an option, it's something you have to use, that does, in this case, the same thing. So I'm declaring also an access column element, naming it using the name attribute. But now, instead of using the type attribute, I specify the type inside or nested to the element declaration using the access column simple type element, and also nested to the simple type element the access column restriction element, as you can see here. And at the restriction element, I use the attribute base for setting the type similar to what we've done at the first simpler example, with a prefix column the name of the type. It also can be a base type from the access default prefix from W3C, or it can be a derived type from any other namespace associated to a custom prefix, as with the first example above. So you may ask why we would use a so much complex syntax for declaring the type of a element with two more elements instead of simply a type attribute here, as in the inline case. And you'll see why sometimes we have to declare the element in this extended form. But in advance, I'll tell you that it's when you have to use other restrictions and not only the data type itself. For example, you can use some other restrictions here for restrictioning the type you've just set at the base here. So you can do a first constraint of the eventual content of this element by using a access column string, but inside the restriction element you may use facets, which are additional constraining elements or attributes inside the restriction elements nested to it that will restrain additionally the possible text content of this element we are declaring. So if you're using a simple base type or even a custom type for setting as the type for your element, and you're sure that you won't need additional constraining on that element, for example, any regular expression for defining a pattern or any enumeration, and only the type will be sufficient for constraining the text content of that element, you can just use and should use only the simpler inline declaration for that simple element. But instead, if you're already sure that you're gonna need additional constraint on that data type, you're forced to use this extended declaration and also the facets or constraints inside here, as we are going to see in the next slides. So basically this is the difference of these two types of declaring simple elements. Before we see the facets or constraints, let's first see the built-in primitive types available from the default W3C namespace associated to the default access prefix. So we have inbuilt to the schema default namespace the access column string type, the access column byte, the access column decimal, the access column int, the access column long, the access column short, the access column any URI, the access column boolean, the access column double, the access column float, the access column date, the access column time, the access column date time, the access column duration, and some others. And as we've said, you can define these built-in data types in two ways: the simpler, using the type attribute, or with the extended declaration using the base attribute at the restriction element. So here are 4 examples: 2 using the inline simpler declaration of a simple element. Here at the first access column element starts the declaration of a simple element. The name attribute names that element, and this is the name you'll be using at the XML instances for this element, client name. And right next you use the type attribute with, for example, the built-in string type from the default namespace of W3C, access column string. So here you are defining a simple element named client name of the type access column string, and here you just closes with a slash the opening tag, and that's it. The element is declared. On this next example here, on the right side, we are declaring also in the simple inline form an element named period of the type access column duration, and then we use the slash for closing the opening tag. Then we have 2 other examples here using the extended declaration type. For example, here we are declaring an element named consultation date time, which would have as content a date time for a certain consultation with some clinician, for example. Instead of, we set the type right inside the element opening tag next to the name of the element, we nest a simple type element inside the element, and we also nest another element called restriction, access column restriction, inside the access column simple type, and use at the restriction element the base attribute for setting the type as the built-in date time from W3C. And here, as we use it, the extended declaration, we could set here nested to the restriction element some facets or some additional constraints, as we'll see on the next slide, for restrictioning even more the text content of this simple element. In this case, we didn't use any facets, so we could also declare this same element using an inline format. The only time you are forced to use the extended declaration is when you intend to use facets or additional constraints other than the type itself. And here, a last example. We declare a access column element named numbers. Instead of the type attribute, we nest to the element a simple type element, as on the last example, and we add to the simple type element nested to it another element called restriction, access column restriction, and as the base value we use the inbuilt data type called access column non-negative integer. So this element will be able to contain text content representing any integer from 0 on. And as you see, we're not also setting any facet or additional constraint other than the type name here. And as such, we could also declare this same element in a inline form. But if you did wish to add some facets, some additional constraints on the restriction type here, you would have to use this extended declaration form. Now let's see two other constraints which can be set inside the opening tag of the access column element along with the name and the type, which are the default attribute and the fixed attribute. The default attribute defines a value to be automatically set when no other value is set to the elements at the XML instances, and can be overridden when a custom value is set by the user at the XML. For example, we can set a color element string value to blue, and if we use the default attribute for setting that blue value, that color element, if no value is set at the XML instance, the color will be automatically set to blue, which is the default we are setting here at the XSD. And if the user decides to override this value, he can apply any other string value representing the custom column he wishes to set instead of this default color. And the fixed attribute, on the other hand, it defines a fixed value that does not allow any other value to be set or to override this fixed value at the XML instances. So if we set the color value instead with the fixed attribute, for example, a red value at the XML instances that would refer to this element, no other string color value would be accepted except this fixed previous defined color, red. So we've seen the data types that we can apply. We've seen the default and fixed attributes that can constrain even more the values of the simple elements contents. And now let's see the built-in constraints or facets on these data values, which are some additional default constraints created by W3C that we can use from the default namespace by using the default access prefix. And for using these constraints, we will generally have to declare the simple element using the extended declaration way. So as a list that I took from W3 schools, these are the facets available by default from the W3C namespace. You have the enumeration that defines a list of acceptable values. You have the fraction digits, which specifies the maximum number of decimal places allowed for a float value, for example, and the value must be equal to or greater than 0. No negative values are accepted. You have the length facet, which specifies the exact number of characters or list items allowed, and it also must be equal to or greater than 0. You have the max exclusive and max inclusive, which specify the upper bounds for numeric values. You have the max length and the mini length, which specify the maximum number of characters or list items allowed and the minimum number of characters or list items allowed. You have the min exclusive and min inclusive, which specify the lower bounds for numeric values, respectively exclusively and inclusively. You have the pattern facet, which defines the exact sequence of chars that are acceptable, and you can use with it a expression language. You have the total digits, which specifies the exact number of digits allowed, and you have the white space, which specifies how white spaces is handled as line feeds, tabs, spaces, and carriage returns. So just for giving you an overview of how to use these facets or constraints on simple elements, here are 6 examples of simple elements declarations using the extended declaration form. The first is an item number element, and here, as we've said a lot of times before, instead of using the type attribute, we define the type as an extended form inside, nested to the element, using the access column simple type, and then access column restriction, using the base attribute of the restriction for setting a built-in type. In this case, as it's a number, we can set access column positive integer, so the text content of this item number element will accept integers starting from 1. And for additional constraint of this built-in type, positive integer, we're using nested to the restriction 2 other elements or facets, min inclusive and max inclusive, all from the default namespace and from the default access prefix, with values, in the case of min inclusive, value equals 1, and max inclusive with value 5000. So the content of this item number element at the XML instances will be any text content of positive integers starting from 1 and going through 5,000. So any number between this interval from 1 to 5,000, both inclusive, can be accepted as the element content value anywhere this element is used at any instance that would refer to the XSD where this simple element is being declared. So here we have another example, now declaring a simple element of name animal and the extended type simple type with the restriction nested to it and the base value of access column string, and inside and nested to the restriction some facets or constraints. In this case, a enumeration constraint with 3 option values: dog, cat, and rabbit, so that the content value of this animal element would be able to contain any string name that would match any of these enumeration options: dog, cat, or rabbit. So as you see, we're not only defining the base type here, or even a eventual custom type, but we are also setting nested to the restriction element additional constraints or facets that restrict even more the accepted values for these elements at the XML instances. Here, a third example of facets. We have a letter text element with an extended simple type being declared nested to the element in a restriction of base string, and we use the facet white space with the value collapse. And the collapse value for this white space facet, all white space characters as line feeds, tabs, spaces, and carriage returns are replaced with spaces, and that leading and trailing spaces are removed as well, and that multiple spaces are reduced to a single space. You can later see the other options for this facet. We are only showing you a general picture of how to use them inside the restriction elements nested to it. And here we have a password element with a simple type element with a restriction element of base string, and as the facet nested to the restriction we have a pattern element with a value being a simple expression language that accepts an 8-digit value, which can be a sequence of lowercase chars, uppercase chars, or even numbers from 0 to 9. So this is another facet, the pattern facet. And here at the fifth example of facets, we have a username element with a simple type element and a restriction element nested to the simple type, and the restriction with a base string, and the facet we're using here is the access column length facet with a value of 8. So the content value for this username element will be a string of length 8. And here another username example with a simple type with a restriction of base string, but now with two facets, a mini length of 3 and a max length of 12. The content value for this username element may be a string with a number of chars from 3 to 12. So any string with 3 to 12 chars will be accepted as the value content for this username element. So this is how you set the facets, usually inside the restriction element, and that's why sometimes when declaring a simple element you have to use the extended declaration form with the simple type element, the restriction element, and with the facet element nested to the restriction element, and not only the base for the type, or if we were using the inline with the type attribute of the element. So now, closing this subsection of simple elements declaration, let's see two real examples with simple elements declarations. The first example, it's a client schema using the simple design method that we've already seen. And the second is the same client schema but using the named types method as the chosen design. So when using the simple method, for you to declare simple elements, you do as we've done here. First, always in any XSD document, you have the prologue, then you open the schema declaration, the opening tag of the schema, which is the root element for that XSD document. Then you set the default namespace associated to the access prefix. You define the target namespace, in this case ending with a client word here, as it's a client schema. Then you set the custom namespace with exactly the same URI of the target namespace for linking the custom namespace with the target namespace, and set this custom namespace with a custom prefix, in our case Daniel PM 1982, and then the element from default is set always as qualified for force using these namespaces and prefixes at any XML instance that may refer to this schema. And then, as we are using the simple method, we open the opening tag for the future root element, in our case here the client record element. Then we start declaring the complex type, but don't worry with it for now. We will still look into the complex type and complex elements declaration. What I want you to see here is the declaration of the simple elements. For example, here we have the future root element, which is client record. Then we start declaring the complex type in a sequence of some simple elements. For example, here a name element using the extended declaration form of the simple element with a access column simple type and a access column restriction of base string. And here inside the restriction we're using two facets, the access column max length of value 50 for limiting the number of chars to 50, and the whitespace facet with the value collapse. So, other than the name element, we have also the gender element declaration. It's also a simple element, also declared using the extended form with a simple type element, with a restriction element of base string, and with two facets, actually with one facet which is an enumeration, and two values, male and female. Then we have the birth date simple element extended form declaration with a simple type with a restriction of base date and with two facets nested inside the restriction element with a access column pattern with the date format here, the year, which is 4 digits, the month, which is 2 digits, and the day of the date, which is also 2 digits, with the hyphen between each field. And also the whitespace facet, also with the value collapse. We also have other additional simple elements declaration, and I've used always the extended form of declaring them here, because I'm also using facets nested to the restriction elements of them, so I can't use the inline declaration. Just if we were not using any facet, we could declare in the simpler form through the inline declaration, but as we are using facets for all of these simple elements we are declaring, there's no way to use the simpler form. We must use the extended declaration form. So here, an email element declaration, also a simple element with a simple type element, a restriction element of base string, and 3 facets, a max length of 50, a whitespace of value collapse, and a pattern with a regular expression that validates an email string value. Then we have another declaration of a simple type using the extended form, which is the address element with a simple type element, a restriction element of base string, and 2 facets max length and whitespace. The max length of value 150. So it's the number of maximum chars for that string type, and the whitespace facet with value also collapse. And finally we have the last simple element declaration, which is a phone number element with the simple type element, a restriction element of base string, and 2 facets, a max length of 20 and a whitespace also with value collapse. And lastly, we have the declaration of the attribute, a client ID attribute, and as the type here, I only use a base type using the access prefix column non-negative integer, and here I declare the attribute for the future root element with a name client ID and a type access column non-negative integer. So observe here that the attribute I declare using the inline form and setting the type using the type attribute instead of the restriction element with a base attribute, as we did on every simple element in this XSD. Then we close the complex type of the future root element, then we close the closing tag of the element, and lastly we close the closing tag of the schema. And now, using the same example, but now with named types method as the design or organization of the declarations throughout our XSD code. So similar to what we do when declaring simple elements, we declare the named simple types by using the XS:simple type element, setting a name for it to be referred later at the element's declarations. Then we add a restriction element nested to the simple type, and we use the attribute base of the restriction. For example, here we set the base with a value of XS:string, and inside we set here two facets, a max length of 50 and a white space collapse. The other simple types are pretty much the same. Then we declare the attribute the same way as we did on the last example. Then we declare the complex type. It's not yet the future complex element here, it's the complex type that the future complex element will use as its type, but still it's a complex type declaration with name client type. At this complex type, we declare each element with the respective names for those elements that the user will use at the XML instances, but with the type referring to the simple and complex type we've already defined globally outside this complex type element. And lastly, we declare the one and only global element named here as client record and set the most complex type with all other types and elements as the type of this future root element, using the custom prefix which directs to the target namespace of this XSD and a column and the name of the type we've just declared outside, which is client type. So that's it for simple elements. Both the two forms of declaring simple elements, the data type setting and the built-in data types available from the default namespace of W3C, the fixed and default constraints you may use, as well as the additional constraints or facets that we can use and how to use them by choosing the extended declaring form for our simple elements in any of the design methods that we choose. Now let's talk a little bit about the specific syntax of attributes and how attributes can be declared and have their types set. Simple elements cannot have attributes. Complex elements, on the other hand, can have attributes, and these are declared similar to how we would declare simple type components, either simple elements as well as simple types. So, inside the body of the complex element, write nested to the complex type element when using the simple method, or outside the body of the complex element, write nested to the schema element as a global declaration, and later that global declaration of the attribute is referred from a complex element body using the ref attribute right inside the complex type element, either at the divided method or at the named types method. As in the case of elements, attributes can have data types, including simple, and complex named types and facets constraining its values. Also, they can use the attributes default, fixed, and use. The use attribute is for defining the attribute value as required, optional, or prohibited. So here we have two examples, one using the simple design method and the other using the divided method. At the first, you can see a declaration of an ABC element, and now instead of a simple type, you must use a complex type element, as there are no simple types or simple elements with attributes. If you declare an attribute, you're declaring it inside or to be referred from inside a complex type or a complex element. So when declaring the element here, we declare a complex type, then the sequence indicator, we'll see later both the complex type declaration as the indicators at the next subsection. But here what you should observe is the declaration of the attribute outside the indicator of that complex type, starting with the opening tag access column attribute, a name for the attribute which is demanded, and the type of the attribute, which can be the default W3C prefix that's linked to the default namespace from W3C. If you're setting a base type, for example, access column string, or any other custom prefix linked to any custom namespace, if you're declaring any other derived type to the attribute. Here you see that you can also use the default as well, and you can use the use attribute, which can be required, optional, or prohibited. So this is the inline declaration of an attribute inside a complex type of a complex element. And here below, when using the divided method or the named types method, instead of you declare the attribute inside the complex type of the complex element, you declare it globally. So you set the name, you set the type, and you may set the default or fixed values. And then you refer to this attribute from inside a complex type of a complex element declaration, always below or next to the indicator in which you declare the elements nested to the complex type. For example, here you could have any number of elements declared as the complex type, and the attribute you declare right after you close the closing tag of the indicator of the elements, as we've done on the simple method. But now you open the declaration of the attribute and you use the ref attribute for referring to the global attribute already declared outside this complex type or complex element. And next to the ref attribute, you can use the use attribute with required, optional, or prohibited values. So these are the two places where you can define an attribute. If you're using the simple method, you declare the attribute right below the indicator, or you can declare it globally, both at the divided method as at the named types method, and then refer to that attribute from inside the declaration of the attribute of the complex type without having to use the type attribute or the default or fixed attribute anymore. You just refer to the globally declared attribute, and you can reuse it any number of times you want, and also use the use attribute here at the complex type attribute declaration. So here are two more examples for showing you how to declare attributes. One example with the declaration of an attribute inside the future root element when using the simple design method, and here on the next example showing you how to declare an attribute using the divided method or the named types method. So at this first one we have the prologue, the schema declaration, the namespaces and prefixes. We have the opening of the future root element called node. It's a node schema. So inside the node element we declare a complex type and a sequence of some simple elements nested inside it. And what I want to emphasize on this example is that you declare the attribute with its name, in this case node ID, with a type, in this case an access column non-negative integer, with a default or fixed values. In this case we set the default to 0, which can be overridden by the user at the XML instance, and with the use attribute, in this case with an optional value. So here is the complete declaration of the attribute for this complex element when using the simple method. And the next example, when using the divided method or when using the named types, you should declare the attribute globally, right nested to the schema as here. Here we declare some simple global elements, and we also declare globally the attribute named node ID with a type access column non-negative integer and default 0. And then we refer to this globally declared attribute from inside the complex type of the complex element, which in this case is the future root element node, right below the indicator, which in this case is a sequence of some simple elements. So after the sequence closes, you declare the attribute, but only referring to the outside declared attribute, which in our case is reached by using the custom prefix DanielPM 1982 node column, the name of the attribute node ID. And you set here the use to whatever you want, in our case to required. If we were using the named types method, it will be exactly the same. The attribute would be declared globally and would be referred even at the named types by using the ref attribute inside a complex type of a complex element. So that's it for attributes specific syntax.